Hello, everyone. Welcome to the webinar, Precision Data 101, RTK, PPK, GCPs, and what they mean for you. My name is Jackie Gilbo, Marketing Director at Skycatch, and I'll be your host for this webinar. I want to first thank DGI for co-hosting this webinar with us, and especially give a big thank you to everyone who joined us today. Precision data is a hot topic right now, and our goal is to leave you armed with all the information you need to make an informed decision about qualifying the solutions out there to help you decide which is right for your next project. Our agenda today will be first some introductions of who we are and the companies we represent. And we have two polls. Thank you for filling out the first one. We want to get to know you, so we'll launch the second one in a minute. And we'll do our speaker introductions, setting the stage of what industries we're talking about, the market evolution from hobby to enterprise, benefits of an enterprise solution, who needs it, what factors to consider before making a purchasing decision, the solutions both DGI and Skycatch can provide, and a customer spotlight. After that, I will pull in as many questions as I can in the time we have allotted from the chat window. Feel free to submit your questions at any point during the webinar, as I will be monitoring them as they come in. So, a brief history. Skycatch has been focused on commercial drone data collection since 2013. We first introduced the integrated multi-rotor drone in 2015, and we're proud to have the largest commercial drone industry in history that DJI is actually helping us fulfill. The Skycatch solution was actually originally developed by our second presenter, Will Pryor, Enterprise Solutions Manager with specialties in implementing tailored solutions for enterprise clients in the mining, construction, utility, and enterprise industries. Our second presenter, Brandon Montalado, Program Manager and former Skycatcher, is from DGI Enterprise. So without further ado, Brandon, will you kick this off for us?
Happy to, and thanks for the intros, Jackie. Hi, everyone. I'm Brandon Montalado with DJI, and I'm our program manager for enterprise solutions. And really what that means is DJI was founded really with a focus in kind of the consumer, which evolved into the prosumer markets, really with a focus meeting a few customer asks in the area of cinematography, videography, ultimately putting together integrated drones that could be very easy to use out of the box. Now, one of the interesting byproducts that we saw from these drones, since they were very, very cheap, so low barrier to entry, but also the integration factor is people started using it outside of what DJI had really envisioned, right? The cinematography world. We started seeing them used in things like photogrammetry, so they were making their way onto construction, mining sites, and all of a sudden you see this evolution bloom. And so what we're going to talk about today is a little bit, what I'm going to talk about today is a little bit about how DJI has seen all of these drones move out of a consumer prosumer market and start entering this enterprise world. And we've seen that in this few specific verticals. So up on the screen right now, I have some of the main verticals that we've been working with our drone technology in. So inspection, agriculture, search and rescue, infrastructure, and then surveying and mapping. Now we're going to dive in today a little bit later on with Will Pryor and the Skycatch team about how surveying and mapping is being used today and what accuracy and data processing really surrounds that. But overall, I think what I would like to do is kind of step back and talk about a little bit of the transition from this consumer prosumer market to enterprise and what that really means. So just to look at some stats, we do have a very good partnership with Skylogic Research. They've been doing an industry report for over 4 years now. And so I wanted to start showing some initial data to the group here, as I think what we really are seeing is this evolution from this consumer drone to an enterprise drone and what that really means. So if we look out the breakout, and this is from their 2018 report, we see a majority of the use cases going to photography, videography, surveying and mapping is the next main majority. And then we have cinematography. And then shortly after that, we have asset and infrastructure. Now, the interesting thing about this data is you look at the photography and videography and cinematography. Those were the main use cases that DJI had designed our aircraft for. And if you look at the kind of next to the surveying and mapping and asset and infrastructure, those are what we would really kind of consider the enterprise verticals that are starting to use the aircraft technology today. So if you really look at this, this makes up almost a majority of the use cases of how aerial aircraft are being used today. And then obviously we have all of the other verticals as well as some academic research, education that kind of make their way into it as well. So the way we look at this at DJI is the consumer and prosumer drone market has been leveraging technology that was not necessarily purpose-built for their day-to-day operations. And that has caused some hurdles with kind of how they use the technology on site. But ultimately, we're also seeing this evolution from photography and cinematography, which is fairly low barrier to entry and easy to use on site, to more advanced data deliverables like surveying and mapping and asset infrastructure. So this has impacted not only kind of how all of the startups that are supporting the drone space work, one of the key ones there being Skycatch, but it's also impacted DJI and our development. So what we've started to see out of DJI in the last year here is actually enterprise-specific drones, specifically with our M200 and Matrice 200, as well as the newly released Mavic 2 Enterprise. I'll talk about those a little bit later on. But the whole goal to kind of paint the picture for the group today is that we've really been evolving from consumer prosumer technology to purpose-built enterprise hardware with the specific goal to really provide a solution, overall solution to the customer. So that's what Skycatch is really going to do a deep dive on. I just want to kind of do a general overview for everyone. I want to continue on with some of the data points from Skylogic as well, as I think they really paint a good picture on what it's like to use drones on site today. And so the figures that you have up in front of you was basically any kind of issues when it comes to managing drone data, images, and then basically processing of any videos or imagery. And by far, speed of processing becomes the number one outlier on this graph here. And I think what that really means is we're starting to see people who have been capturing data, processing it either on site with a fairly powerful computer or potentially in the cloud, which depending on your connectivity to the internet can take time to move large amounts of data. And so this does have an impact from an actual deliverable to end customers, as now we have to factor in how are we really processing and moving this data. And then I think some of the other big issues that Skycatch and Mr. Will Pryor will be talking about later on here is looking at things like these data exports, as well as kind of analytics, right? So great, we need to process the data. Once we resolve that issue, how does that data either move within our system or teams? And also, how does that help us make decisions, right? And we really look at this as the total solution, what really needs to be designed for enterprise customers to be leveraging drone technology. Now, towards the end of my presentation, I'll definitely talk about some of the key factors that we see as far as the larger customers with fleets of hundreds to thousands of drones to make what they've developed to make them successful. But I really do think this data kind of starts painting a good picture of how the industry is progressing. And really what this means is the adoption curve, right? So how are people moving from the early adopter phase to early majority, late majority, and then to the people who unfortunately probably won't adopt technology and kind of potentially get left behind. And some of the data that really kind of caught my eye from this report was improving accuracy. So the data we're seeing in front of us here is of the 1,000 people that were interviewed, what type of accuracy improvements do they employ when they do capture photography or videography for photogrammetry reasons? And this actually was a little bit shocking that 40% use nothing. So essentially they're flying the drone today, they're leveraging the GPS on the drone, which is fairly accurate, but when you want to start looking at survey grade or high accuracy data, it's definitely not designed for that specific purpose. And then I think we see kind of the next lower barrier to entry is adding ground control points. And these come in multiple forms. I mean, it's everything from people just, using spray paint on the ground to actually laying down either, tarps that have kind of a symbol printed on them. And then we have all the way up to, purpose-built ground control points. But this can be quite consuming. And it's also a little bit of an art as where do you lay these down on your site. So I think the question then becomes, what is the real answer to leveraging drones? Because right now we're looking at nothing or ground control points is a vast majority of what people are doing today. And so most of the surveyors that we have on the call today, they really are going to be kind of in their heads probably saying the obvious answer is looking at solutions like RTK and PPK. And these, unfortunately, right now are the minority stakes of what we're seeing on in the market. And I think there's a few reasons for that. As we were talking about the consumer and prosumer models that are a majority of what's being used on site, none of those come with RTK or PPK possibilities. And again, Will's going to do a deep dive on what RTK and PPK really are as far as GPS technology. But the reason for this is up until recently, most drones needed to have additional sensors put on them to actually get to either an RTK or PPK capability. So this meant modifying existing hardware or potentially building custom solutions. And that's obviously very burdensome for a lot of our enterprise customers and has a lot of difficulty scaling. So I think the interesting thing about this graph is how we see the adoption curve growing. And ultimately, if we can lower the barriers to entry on some of these more advanced GPS technologies, how will that impact data deliverables? And Will's going to do a great job of talking through some of the customers today and how that really drives the workflow on their sites. So last, I have a few more slides here, everyone. And I think what I want to start painting the picture of is, again, this adoption curve and where we're moving. And so this was a great data set that I really enjoyed from the SkyLogic team. And it basically shows drone spend in the last 12 months, so the last year versus the next year. And really what we're seeing is the drones that are under 10,000. So we kind of think of these as the consumer prosumer level aircraft. We're actually seeing a decrease in spending. And there's probably many reasons for that, but I think some of the ideas that you can extrapolate from that data is that ultimately a lot of people have gone through this early adoption cycle where they've bought some consumer drones, maybe it's a Mavic, a Phantom, flown it on site. They've gotten some really good data from it. They see promise. But now the question is, how do we improve that data accuracy so we have more consistent workflow? And ultimately, how do we integrate that into our other systems? And also our managers, how do they leverage that data? So I think this is where we're starting to see a shift, and we're starting to see an increase now in systems that are a little bit more expensive. So the 1,000 to 50K, I'm sorry, the 10,000 to 50,000 range, and then the 50,000 or more, I think, are probably the minority players still. But we're definitely seeing an increase in these systems that are a little bit more expensive because we're now reaching this point where we need to start scaling across our enterprise platforms for these customers. So a lot of the customers that I work with are, drone fleets from, 50 drones up to 1,000. And for them, they really need to move past the consumer grade drones because they have higher requirements for their data accuracy. So this chart, I think, does a great job of kind of highlighting that we are moving past this early adopter stage and into this early majority and kind of what that means as far as adopting the technology. And so just so everybody has a maybe clearer picture of what these price points really associate to, I kind of have a linear chart here of what the drones that we're talking about today. And so I think a lot of the early adopter drones that we're seeing are platforms like the Mavic 2 Enterprise, which have, a good camera on board, a great GPS as well. But again, it's none of these RTK, these high precision solutions that you can really get. And so they're a great starting point. They fold up. You can fit them in a glove box, very portable, but they're only going to get you so far. And so I think as we progress along that, DJI did just release our Phantom 4 RTK. So this is basically a modded out Phantom 4 with a high precision GPS on board. And so this starts to provide a transition from the kind of consumer prosumer aircraft to actually adopting an out of the box aircraft that has a little bit higher precision. And then I think you start moving all the way into what I would kind of classify our enterprise aircraft. And these start taking the form of the Matrice 200 series and the Skycatch Explorer 1. Now, these are purpose-built to operate on, construction, mining, surveying sites where you have a lot of dirt constantly in the air. Things get dirty very quickly, and so you need to have hardened and ruggedized equipment. And that's exactly what these machines have been designed to do. And then I think you have kind of outside of this hardware, you have the full processing software, and then you have training and support. And so that's kind of where I wanted to bring us to as I start to close my part of this presentation is what we've seen a lot of our key customers who do have large scale drone fleets that are operating across potentially global regions, what they've really had to employ. And we see this taking kind of 6 core pillars. So we see this as platform. So really what the drone solution is, we need to kind of move away from toy hardware and start looking at something that is rugged, that can handle transportation and operate on sites. We start looking at payloads, right? So how we look at the camera, but in this scenario, I would also like to talk kind of the GPS, right? The payload is kind of the overall system to improve the data accuracy capture. And then we have things like software, training, support, and then ultimately integration. Now, Skycatch is going to talk to you about their stack and how their stack kind of fits into these core pillars. But just to kind of leave everybody at the table here, what we're really seeing is a lot of these companies that have scaled either have all 6 of these or are working to fill them out. But these are kind of the core principles that we see today. And what that really means for customers that are adopting these 6 principles is drastic increases in efficiency. And so some of the figures that are out there today, I mean, we've seen from a surveying standpoint, drones collecting data 97% faster than manual methods. Now that can be, you know, a rover, that can be LiDAR, so that's kind of a loose stat. Ultimately, it is drastically faster than having somebody out in the field. Drones can quite easily cover 50 to 100 acres in a single flight, depending on your accuracy requirements. Next up is you kind of have better information. Since the time to capture is so drastically reduced, we are now seeing people capture data more frequently, right? So if you have just everybody sitting in the office and has a question about takeoffs on a specific site and, you know, where they're really at from a cut fill perspective, instead of sitting there guessing, you can actually go out and quickly get the information you need. This basically starts improving asset productivity because now you're making decisions quicker, making sure equipment is where it needs to be. And lastly, you don't have somebody out walking around the field that doesn't necessarily need to, right? The drone does the perfect asset to use when working in a hazardous operational environment is a robot. And that's exactly what the drone is. It's just an aerial robot. And then lastly is kind of that storing, tracking, and distributing data. And that means a lot of things. So not only sharing with your team to kind of get the maximum efficacy from it, but also leveraging this data more long term. Everybody who's talking about AI out there today, you can't just come out with a perfect algorithm and feed it into your model because you need to have all of these images that you build your AI and computer vision models off of. And so a lot of our users that are collecting this data at scale, this actually feeds into kind of longer term thinking about how their operations are going to really solve long-term problems. So thank you, everybody. I hope that was kind of a good outline of kind of how DJI has seen the industry grow, how the technology from a hardware perspective has definitely been evolving from this consumer prosumer into an enterprise solution. And I'd like to have Will talk a little bit more now about how Skycatch is actually solving these problems with their Edge1 and Explore1 platform today.
That's great. Thank you so much, Brandon. And I think we're going to do another poll here. So let's see. Let me introduce that poll. Oh, maybe not for this one. Okay. So back to the presentation. Yeah. So just for a quick bit of introduction. Okay, great. Yeah. So while the group here is voting, I'll do a quick introduction. My name is William Pryor, and I've been a enterprise solution manager with Skycatch for a few years. And this is a picture of me actually. Got it. So this is when we finish the poll, I think what you're going to see is a picture of myself at the Komatsu America training grounds in Georgia, where a lot of what we've learned here at Skycatch has come from the earth moving and the construction space. And I saw in our initial poll we had 70% of our attendees coming from the construction industry. So these are I'll be speaking a lot sort of with that angle, but I do think sort of no matter what your specialty is, we want to cover why RTK is beneficial for you to use. Great. So, and again, thanks, Brandon, Brandon recapped a lot of interesting information kind of about the drone industry today. And I think what we've seen, one of his slides on the common drone spend is that we see that there's been the sort of testing phase, there's been the evaluation phase of using drones in construction, and I think in the past 18 to 24 months, we've seen a huge uptake of drones on construction sites, and I think most construction sites, most job sites, now it's very frequent to have drones there. And now that this technology has been proven, it's something that's advancing, people are investing in. And what I'll cover today is really all about why, if you're not using RTK today or a high precision technology like PPK, it's a huge benefit to what you're doing. No matter what that sort of goal is, whether it's construction, mining, agriculture. So why are we talking about this? What really brought us together today? Well, certainly we want to talk about RTK, high precision data. And I've got I like to start this with a quote, believe it or not, from Aristotle. You cannot manage what you cannot measure. And so as we see the uptake of drones in the commercial space, they're becoming an important part of the business process. Now, the feedback, the sort of information that drones provide into business processes, it has to be a reliable source of information, right? We've seen for all the drone service providers, for example, who are on the line. I'm sure that you've had experiences with customers, struggling to get precision data, and that's something that we've all kind of grown through in the industry. So knowing that you have accurate data really is a significant benefit of RTK. We've seen, topography mapping, the kind of cut and fill, quantity takeoff, engineering work is probably the biggest use of commercial drones outside of cinematography now. So it's quite a mature use case, and we see that in this mapping world, RTK and PPK is really becoming industry standard. And again, reasons for that are going to be that it provides extremely predictable accuracy, very reliable and repeatable data. And importantly, if you do work in construction, mining, these are extremely safety sensitive businesses, right? So commercial applications demand that the lowest risk path be taken. And when you're not setting ground control, when you're using a high precision system, you're significantly reducing risk on sites and turning data around faster, which is something I'll talk about. So at the end of the day, there are many different use cases for drone data, all the way from just, visualizing the site, sending a video, maybe a progress update, all the way to, integration into BIM, integration into your earth moving workflow. And really RTK makes it just as easy to capture survey grade data as it does to take a video. And so that's why it really enables the highest value features and why it's something that we should all know about. So I'll give a quick sort of technical history of Skycatch here. From the beginning, we knew that there was really incredible source of data in the world, in the sort of built environment that needed digitizing, and drones were an amazing vehicle to do that. When we started the company in 2013, it was really hard to actually do this, just to fly drones, program waypoints, and things like that. So making it easy for people to get this data source, so they don't have to think about the drone very much, they don't have to think about flying very much, they're really focused on the data. Making it easy to get that accurate data has been our sort of guiding principle from day one. And you can see here in 2014, one of the things that we innovated was automatic GCP recognition. So at the time, we had a significant fleet of drones that were deployed, used by customers all over the world, and using ground control points to locate this data. And anybody who's sat in front of a photogrammetry program and clicked GCP after GCP, they know how time consuming and frankly error prone this can be. So we decided to make that a bit easier just by making the GCP identification process automatic. As a next step, in 2016, we introduced Evo 3, which was our really the market's first RTK integrated multi-rotor. So we had a proprietary platform. We used our basically fully integrated our RTK system on there that was used with our cloud processing solution. So what this meant was that these you no longer needed to set ground control for processing accurate data. And when you're actually not doing that, it does introduce a lot of complexity. Some of these things I'll talk about. But ultimately, this was our sort of next step at making it easy to get that accurate data, right? No longer is there a ground survey needed. And as a final step, just last year, this really hit the market and got a lot of interest and popularity, something I'll talk more about today, is the Edge1. So the Skycatch Edge1 is a RTK and PPK base station. So it provides GPS corrections to RTK-enabled drones. And it's also a processing unit, right? So what this does is it's a lot like having a photogrammetry engine inside of your RTK base station. So processing is done in the field. It comes packaged with our Explore One high precision package. And so what that provides is an ability to just fly the drone, process data on site. Now, we'll get to covering some basics about the technology that I think a lot of the attendees here want to understand. So let's just get this out of the way and talk terminology. So RTK, PPK, it's discussed a lot today. We have the Phantom 4 RTK. Then there are other drones. EB Explore One is one too that operates with RTK and PPK technology. So the basic idea of RTK and PPK is really pretty straightforward. A given GPS receiver that's sitting on the surface of the Earth, it's going to measure it's going to be receiving satellite signals that are wavering in space a little bit, just like when you sit when you're looking up at the night sky and you see stars twinkling. Well, those changes in the atmosphere that are happening also affect the radio signals from the GPS as they come down to the Earth. So that's why we see with a single GPS the best accuracy you can get is something like 10 meters, 30 feet, right? That's what we would call just a coarse GPS position. Now, it so happens that when you have two GPSs that are, in the same vicinity on Earth, and so in our case, that'll be, say, 10 miles, maybe 20 miles, these two GPSs, they see the same error that's induced by the atmosphere, right? So two GPSs in the same place on Earth see the same error going to those GPSs. So what does that mean? Well, if you put a high precision GPS in a known location and you tell it where it is, that's going to be called our base station, which we're showing on the screen right here. We have a base station on a tripod. We know the position of that GPS, but at any given point in time, that GPS is going to be measuring a position that's slightly different than where it's actually sitting. And again, this just comes from the normal errors induced by the upper atmosphere. So instead of measuring a position, let's say where that GPS is sitting, it'll be measuring a position off to the left as being shown by this red arrow here, right? So the GPS is in a known position, it's measuring somewhere else, and so we can resolve that error. We say, okay, well, the GPS should be here, but it's measuring over there, therefore we have a known error. That we'll just call that a correction, right? So we've established the error, we've established the correction, and the next thing that we need to do in order to correct the GPS position of a remote GPS, which in this case we'll call the rover, we'll broadcast that correction. It could be over a dedicated radio link. It could be over cell service as well. Those are two ways to do it. We're going to broadcast that correction to the remote GPS, again here called the rover. And we're going to say, okay, well, you might be measuring this position over here, but in fact, we know that in this general vicinity on Earth, the GPS error is 2 feet off to the left, and we're going to add it into that GPS position for the rover. So this is a generalized technology. I think it's been very common in land surveying for over 15 years. Really, I think potentially even more than that. But the complexity and the cost has gone down significantly. So whether it's on a drone or actually even if you're using ground control points, the chances are you're measuring your locations with an RTK or PPK type of system because you're receiving GPS corrections, right? So even if you're setting ground control points, if you're not using a total station, if you're using anything with GPS, it's going to be based on the same technology. So really what Skycatch has focused on in creating high precision data is bringing this system from the ground into the air. Here I'm going to kind of lay out what that looks like. So the data really the accurately referenced survey data that we're creating with drones, it's a combination of two things. One is going to be the actual photogrammetry step. So I won't cover this in too much depth, but basically what's happening is, when drones are flying, you're using an app like DJI Map Pilot GS Pro, or for example, Skycatch Flight 1. The drone is flying and taking a photo on a routine interval, something like once a second or once every few seconds. So as we fly over an area, we'll take, say, a few hundred photos, and each of those photos is going to overlap significantly into any adjacent photo. So we'll typically see like 5 to 10 photo matches over a given area. And just the way that our eyes see depth when we look at them, when we look at objects in the real world, we see depth because our eyes are in different places, in our head. Well, the drone data that is collected, these two adjacent images, they constitute a stereo pair. So, the very sort of brief explanation of this is, how do drones create 3D data from 2D photos? Well, it's doing a basically stereo imaging. And when that's done on when that's done with a large number of photos, we call that photogrammetry, or SFM, structure from motion. So those are two words you're going to hear in the industry regarding, how this process works. So we've got the photos, and we've now reconstructed our 3D picture, right? That's below it. Well, in order for this data to really be usable for a lot of different things, a lot of our mapping, requirements do need high precision, right? A standard GPS that's on the ground is going to measure somewhere around 3 centimeters, 30 mil vertical resolution, right? Vertical accuracy. So if you want to replace ground-based mapping, with aerial mapping, often the expectation is that you're going to have to meet the same accuracy requirement. So till now, and Brandon actually gave a great overview of this before. I think this is where the process stops for about half of people in the market. They conduct the photogrammetry. They use the coarse GPS position, which could be off by 10 meters up to 30 feet. And we do see that pretty commonly. So it's really not survey grade data. For the vast majority of the market that we see, ground control is being used. And so basically what that means is, as you see in the image here, targets are set on the ground. The positions of those targets are established with a survey device, whether it's total station or GPS. And then basically the 3D output is stretched and positioned into place using these targets like pins, kind of holding it down to a pin cushion. So that's using ground control, right? And I think again, according to the stats that Brandon put up before, about something around half or maybe just less than half of users of precision drone data are using this method, and that's what we see today. But the fact is, the RTK technology now has become easier to use than ever. Skycatch, we provide a fully integrated solution with the Explorer 1 and Edge1, processing this data really without needing to survey the sites at all. And ultimately, how do we do that? Well, we use just like in the previous slide showing, actually I'll go back to it here, we've got our base station sitting on the ground. In our case, that's the Edge1. We know the position of the base. It's measuring an error. We save a correction, and then later on, we apply that correction to the photo location from the drone. So instead of having, say, 10 meters of error in our GPS positions as we fly above the surface of the Earth, we're really more like 2 to 3 centimeters error in absolute space. And if you do all the photogrammetry right, then that error really resolves out into the output. So we're generally able to correct the data as well. The data output generally will match the GPS correction accuracy of the photos themselves. So I mentioned Edge1 here. I want to show a picture of it and just talk about what it is and what it does. I just covered really two pieces of technology, right? How do we get the data? Well, we get high accuracy GPS corrections, and then we do photogrammetry. Well, that's exactly what the Edge1 is designed to do. The Edge1 is a RTK and PPK enabled GNSS base station. So we're measuring GPS, we're measuring GLONASS. So really able to be used all around the world. And it's currently deployed on something like 6 continents. On board, so this is not just a rover, and there's a reason we call it, it's not just a GPS, and there's a reason we call it an intelligent base station. It has a quad core CPU on board, an NVIDIA GPU, a significant SSD, and we can do photogrammetry processing directly on board. So by using the Edge1, we can process multiple different file types. That's point clouds, mesh, orthophoto, and we even do some object removal if you want to get down to a bare earth surface. So really this is like a photogrammetry computer in a box with a GPS attached, it can do GPS corrections, and it does all the work for you as far as data processing. So really quite a change from the normal workflows I think that people are used to, and there's really nothing like it on the market today. Just as a sort of addendum to that, the Edge1 with the NVIDIA GPU that's inside of it is able to actually process machine learning models and some artificial intelligence models. So we can stream live video into the Edge. It's not just serving as our base station, but now it's providing some intelligence in the field. So actually, if you go to the Skycatch YouTube page, you can see what we've been up to as far as our AI, our AI and machine learning projects. So it's really a multiple use field computer focused on photogrammetry. So, we talked about how RTK works. We talked about photogrammetry and the Edge1. I just want to talk a little bit about exactly how you use the Edge1. Okay, pretty simple, and again, it really combines a lot of steps that are different steps in the sort of normal mapping workflow, right? GCPs, processing on a heavy-duty computer, delivering data, storing data online, etc. So to use the Edge1, we bring it into the field and we turn it on. The first thing that the Edge1 does is it can talk to an RTK network and self-position, right? So that first piece of the information that we need, what is the base station location? Well, it'll determine that automatically. The next thing it does is it starts logging the corrections. So it knows where it is. It's aware of the GPS position that it's measuring, and it begins logging those corrections on board. The next thing is we fly a drone that's RTK or PPK enabled. So RTK is not so much of a proprietary technology. And so, right now, the Edge1 is primarily used with the Explore 1, but we are exploring compatibility with the Phantom 4 RTK, coming in 2019. So and I just want to make a note, that is an important piece, right? If you're using the Edge1, you do need an RTK-enabled drone in the air, right? In the air as a component. And again, we do provide that Explore 1 as part of our high precision package. So we'll fly an RTK or PPK mission, basically where the drone is taking photos and it's saving GPS information about how it established its GPS position. The drone lands and we load photos onto the Edge1. So when the photos are loaded onto the Edge1, that GPS information from the drone, from the rover in this case, is also saved on board the Edge1, and then we go to process. So the first thing that the Edge1 does is it will process the data with high accuracy, right? PPK or RTK as needed, depending on the air system. So we get all of our GPS corrections from that 10-meter area down to the 20 to 30 mil area. And then very simply, we select our processing quality, select our processing density, file format, and then different outputs. And you can see we can create a mesh, we can create an orthophoto, we can do object removal, and then we provide that data in a projection of your desire. And actually, this is something that Skycatch kind of has developed a lot of specialized knowledge around, creating this this localized data, right? So if you have a site, if you're in the US and 70% of US sites have their own coordinate system for these sites, we can take a localization or a site calibration and project right back into that local coordinate system. So, this is one of the reasons why Skycatch claims, we're able to completely eliminate the ground survey portion. That's because you don't need to set GCPs to establish the local coordinate system. We can just project right into your local coordinate system. And we'll export different file formats on the spot. So the workflow is a bit like a laser scanner, right? You bring it into the field, you use it, and you get a point cloud on the spot. You can bring that right into your CAD program or however you like to use the data. Processing times for a 30-acre area will be something like, say, an hour. And let's just kind of think about this workflow again. We did a time analysis with a customer here in the States. It was a 30-acre site, and they're requiring high accuracy flights 3 times a week. So we do work with a lot of companies that are flying routinely. Drone data not only drives business processes, but it's an important kind of insurance policy, right? It basically recording everything that's done on a given day. So they're flying 3 days a week. For the 30-acre site setup would have taken 2 hours, setting 8 to 10 GCPs, 15 minutes of flying, drive to the office, upload the data, process the data, download and then provide it to the site team, right? So from start to finish, because we're setting GCPs, one, and because we're manually clicking those GCPs and taking time to process those on our computer in the office, our total delivery time is almost 8 hours, right? Basically a whole day of time. I'm sure again the drone service providers, the folks who are collecting data with ground control and construction, mining, they're going to be quite familiar with this sort of workflow. For those who are using the high precision package now, it'd be great to hear from some on the call. We simplify the process a lot. You don't need to set ground control, right? Go to the site, pop the drone out of the box, the drone will fly. Edge1's running in the background. When you're done flying, we'll put the data on the edge and process in under an hour. I've seen some data sets complete, for example, in the mining world where turnaround time is critical. We'll see data sets completing in under 20 minutes, right? So the time to date is really unsurpassed here. And in this case, we're looking at 8 hours versus an hour and a half, and significantly less coordination to be done. Time is money, right? So the time it took, those 8 hours of input time, yeah, I think we're not going to charge the computer for running for 2 hours while it processes your data, but it does take time to set those GCPs, and sometimes setting those GCPs is not even possible. Sometimes areas that you need to map are not reachable, or it's unsafe. But regardless, if you're paying a surveyor, or if you are a surveyor, and you know the value of your time, going and walking the site, setting ground control is something that we're trying to make. We're trying to help those people focus on higher value work. So at the end of the day, that one output that you're getting using GCPs, could cost $6,300, and that's flying 3 flights a week for the month. Where the high precision package comes in at under 1/10 of that, right? So we're not taking any time to set ground control. We're not taking any extra time to process data. We're just spitting data out right from the Edge1 on the spot. Okay, so now, why'd you join the RTK webinar, right? Well, we came to talk about RTK, and really drone data is about the value of drone data exists in the applications that they're used for, right? So, and part of my message here is that I want to convince everybody, if they're not using RTK technology, they should be. And it's because you uncover a tremendous amount of value in the kind of applications that you can achieve. So as a sort of, as a way to think about this, I think about a pyramid of applications, right? Where on our vertical axis, we have, the value of the application, which is related to the required accuracy for the application. And then the x-axis is our number of users, right? So we have a lot of people today. I think, again, Brandon showed about half, right, of people are not using any kind of correction for the maps that they're making. So I put that in the, call it at the bottom of the pyramid, right? Quantitative, low accuracy data, right? You've got a map, it's not really referenced. You can use it for site coordination and maybe updates, but you can't really trust the survey data coming out of that. A step above, is going to be survey enabling functions, right? Things that surveyors will provide to customers, topo mapping, earthwork, cut and fill, things like that. And at the very top, I have LiDAR-like functions. So these are things where you're doing BIM integration, right? It's for all the BIM folks who join, and I think we do have a number of self-identified BIM people in our last poll. This is where you're bringing the drone data in to be used just like laser data. Well, why does this matter? Well, the fact is GCP workflows enable all of these applications. So does RTK. So if you're a drone service provider, who has not necessarily invested in survey gear just yet, you're operating sort of towards the bottom of that pyramid on that quantitative low accuracy scale. By going to an RTK system, you jump to the top of the pyramid and you save time in the field. You're also not walking the site and seeing significant safety benefits, right? So basically with RTK, it's just as easy to collect accurate data as it is to, take a DJI out of the box and make a video. That's really what the message is here, that RTK enables these high value workflows with significantly reduced time in the field and exposure. So very briefly, just kind of to wrap this up, I do want to talk about the value, right? Brandon identified that, while a lot of folks are not necessarily using high precision data coming out of their drones, they are being more willing to invest in these systems. The maturity of drone applications is significantly growing in industry. One of the things that one of our customers identified, this is a mining company, that they were able to reduce the survey time for working areas in their mine from 20 hours down to 4 hours. So they can turn data around much quicker, 75% in this case. Because they can turn data around quicker, they can measure more. So by measuring more, they're able to identify just a very small, they're able to increase their accountability basically by 1% for work that's being done on the mine. And in this case, this is $300,000 of ROI just on one site. So quicker data, more often, more accurate. This is really at the top of the pyramid, I would say, from our one of our partners, DPR Construction. They're flying the drone every day, primarily for site updates. But DPR has become a great user that's flying every day on a number of different sites in the U.S. Now, they're not necessarily shooting for super high precision application all the time, but it's just as easy to create these high precision applications now as it is to take a regular, standard accuracy drone map. In this case, they found that the location of some of these conduits was coming out of a channel in the wrong place, right? If they had put concrete over this, if they had not identified this in time, this would have been a $500,000 mistake. Go back, do the rework, impact the schedule. But because they had this data coming in, the superintendents can remotely, verify. They don't even need to be in the field to see these kinds of errors come in. So significant savings there. A very common one that we see. So if you're in construction, like I think it was about 70% of our attendees, and you're working for a general contractor, well, verifying the work that subs are doing is a huge application for drone data, and it is why we see a lot of companies adopting daily scanning. The thing is, with a regular drone mapper just taking a look, you can say, okay, yeah, the work was completed. When you have high precision data, you can really start to quantify that. You can really measure. Our subcontractor said they put out 90,000 square feet of, ground cover today, or, they build us, they build us $100,000 for the rentals that we use that were on site for 2 weeks. Well, again, when you have high precision data, you can very accurately sort of measure the work that's being done. In this case, that saves a lot of time from superintendents just walking the site, right? Walking the site, making sure that work is being completed the way that it's intended. And in this case, sort of allowing those superintendents to do more of what they're good at, to do more high value work, is worth $80,000 a year. $800,000 a year to DPR. Again, focusing on moving those folks to higher value work. So, just to wrap up here, and I think we're going to have a Q&A right after this, but I want to sort of seed some ideas in the audience about, what does this mean for drone data collection, right? What are we going to see in 2019? The P4 RTK is on the scene, the Edge1 is on the scene. Well, for one thing, you can collect always accurate data whenever you want. You don't need to worry about setting ground control anymore, if hiring a surveyor to do that, right? Exposure risk for surveyors is nearly eliminated. I've met surveyors with bad backs, bad knees from, walking sites their whole career. And being exposed to significant risk, right? So that risk is now eliminated because we don't need to set ground control. In that same sort of token, on the same page is we're increasing the efficiency of our time in the field, right? So we're not needing to walk the site. We can show up on site, start our Edge1, do the flight, and then we've got accurate data without having to set ground control. RTK, PPK data is more accurate and more consistent than with ground control. Anybody who's set a GCP and then found that it moved later on knows that. So very simply, we actually are getting more accurate and consistent data. And for the big businesses that are out there, addressing big data with artificial intelligence and machine learning, this is a better source of data for those processes. And I want to kind of end on this, that I think we're actually going to see a leapfrog effect in drone data. And what I mean by that is, the 45% or so of people who are mapping today, like Brandon showed before, with the availability of RTK systems that are out there, I think we may see that the whole GCP process gets skipped, right? That the industry moves from, industry standard of using ground control. As we see this industry growing, we may see those folks skip right over ground control and going straight to the RTK systems because of the savings, the safety improvements, and the accuracy improvements that we see. So right now, I think we're going to open it up to a Q&A. So I'll actually hand it back over to Jackie to moderate that Q&A. So we look forward to your questions.
Thank you, Will. So we got a lot of questions about how to get a copy of the presentation. If you registered with a valid email address, you will receive a recording of the presentation and the decks themselves. So I will give you guys a couple seconds to input your questions, but we do have a lot related to accuracy. So I recommend everybody that is interested in the Skycatch solution to go to skycatch.com/accuracy and read our surveyor proven white paper. I think that will help answer a lot of questions. So let's start with Brandon. Question for you. Does anyone know if the P4 RTK costs more to insure versus the P4 non-RTK?
It's a good question. So the P4 RTK is more expensive than the standard Phantom 4 Pro. Depending on what insurance provider you're using, that will have different implications in insurance tiers that you would kind of fall into. So again, it's kind of dependent on kind of where you're getting your insurance from. And so I'm just going to kind of go through a few other questions here that we were looking at. So when inspecting and modeling, let's say a point cloud triangle mesh, tall vertical structures, 1,000 feet tall, how much does RTK improve Z-axis elevation accuracy? So good question. I'm going to probably let Will talk a little bit about this again, but I think as soon as you start to see the vertical axis go up, there's really two factors that involve in that. What is the structure you're looking at? If it's when you're looking at photogrammetry, if it's a fairly uniform structure or a mirrored surface, RTK is not really going to make any improvements because you have imagery issues there. So the overall core processing is going to have kind of fundamental issues. But that being said, RTK drastically improves the accuracy, which if you ever look at GPS data, X, Y is normally pretty good. Z is always where you have a lot of variability. And even within our drones, we do things like sensor fusion, where we include a barometer reading to actually help try to stabilize the Z-axis. All that aside, RTK will absolutely improve overall accuracy. Going up to 1,000-foot tall building is going to always be a difficult task because it's going to be what you're photographing. Now, in the world of mining or something like that, like a pit mine, for example, as you go vertical and you still have a very feature-rich wall that you're looking at that has probably a lot of dynamic changes as you go through different soil types, that's a perfect example of how photogrammetry will be able to stick with that process, and RTK accuracy will definitely improve overall accuracy as you go vertical there. Next question here, we have one around M600, and the question is, what about the Matrice 600 for heavier payloads such as LiDAR, multispectral or hyperspectral imaging? And then the real question is, do you consider that the same class as the M200? Great question. So the Matrice 600 and Matrice 200, even though they have the same namesakes, are quite different as far as a platform goes. The Matrice 200 is IP63 rated, so that has some like ingress protection from water and dust. The Matrice 600 doesn't. It's actually really designed as a heavy lift platform or a developer platform, so it's quite open. And your overall time with on-site is going to be a little bit probably burdensome on that equipment since it's not sealed. That being said, the Matrice 600 for carrying heavier payloads like LiDAR is definitely a well-used product today. There have been LiDAR units that have been adopted onto the M200 platform. So realistically, it becomes a logistics approach for you. If you're scanning small sites, I would say anywhere between maybe 50 to 20 acres. A Matrice 200 platform would still potentially be a good choice from like a LiDAR hyperspectral solution. But the problem is you are kind of maxing out the payload of that platform. So the Matrice 600 really, even though it's not designed for those industrial use cases, will provide you significantly greater flight time. So it's really a logistics question on kind of what size sites you're flying. So let me do one more question here, and then I know there's quite a few for Will, so I'm going to go ahead and send it back to him, but I have two more questions I wanted to go through here. Does anyone know if the P4 Pro or Phantom 4 Pro RTK cost more? Oh, I'm sorry, that's a repeat question. Let me go to this last question here on the DJI side, then I'm going to hand it over to Will. The question is, am I correct in stating that the RTK built into a drone like the Matrice 210 RTK is for its own positioning but does not extend to the images the Edge would require, the Edge1 specifically to Skycatch would require in order to do basically all this photogrammetry processing without ground control points? This is a really, really good question. And we kind of talk about RTK in multiple forms here. And so DJI has been using RTK specifically in the Matrice 210 RTK as a differential GPS. What we really mean by that is it's a navigational piece. So if you're operating in an environment where you have interference from a magnetic standpoint, so around high power lines, if you're in a mining situation around heavy ore bodies like iron, that will basically throw off your magnetometer. Ultimately, it's a very, very crippling effect on the drone. Since GPS tells us where we are on Earth, but not what direction we're facing, as soon as we lose that magnetic signal, the drone actually can do quite interesting things. So DJI has leveraged RTK on our Matrice 210 RTK for the specific purpose to maintain heading in electromagnetic interference environments. Now that RTK data does still get geotagged to the photo, but the question becomes how quickly. And so I think what we really need to talk about here is the RTK data is there, it exists, but you start to see delays. And this is kind of a hardware sync question. How quickly can we geotag that data to the image itself? And unfortunately, that's not what our system really was designed for. So you do have improved RTK accuracy. You have kind of tolerances when it comes to electromagnetic interference. But if you're really looking for deep precision accuracy, that RTK is not designed for that. Now, conversely, the Phantom 4 RTK it is not a differential RTK system. It is a specific system designed for mapping, and we have improved drastically our geotagging on that system. And obviously, we'll be making future improvements as well on other aircraft as well with specific focus on mapping. So thank you very much for those questions. I'm going to hand it back over to Will.
Great, thanks, Brandon, and good info. Yeah, I think basically on that last comment, shutter timing is a crucial component of any high precision GPS system, right? So we need to know exactly when we took the photo to know exactly where we took the photo, and that's something that that's been resolved, I think, on the DJI side, and also on Skycatch. It's something that's been part of our sort of offering for some time, is getting that accurate photo timing is crucial. So I'll just do a couple really quick because we just have a minute left here. Yeah, we got questions on accuracy, right? So how accurate is the data when mapping, i.e. within how many centimeters? So what we've seen is with really few limitations, we can usually achieve photogrammetry that's as accurate as the input geotags, right? So what we see is that the geotags will be resolved down to about 20 to 30 millimeters, right? 2 to 3 centimeters. That's just shy of 1/10 of a foot. And flying at lower altitudes, let's say below 200 feet, you can achieve down to that 2 to 3 centimeter accuracy quite easily with Skycatch processing on Edge1. And actually, if you're interested, on the Skycatch website, we do have a white paper where we covered the kind of accuracy results that are achievable. So 200 mil, 2 centimeters, so under 1/10 of a foot is really not hard to do. Let's see. Does the user have to be a licensed surveyor? This is a great question, and I mean, at the end of the day, this is a tool, right? So surveyors do like to use these tools because they reduce their time in the field. There are things that surveyors always will need to be involved with, of course, creating legal documents, engineering documents, things like that. But we do see a lot of folks also self-serving some of this information. For example, for that invoice verification piece, that's something that companies do self-serve using survey quality data for their internal use. Then let's see, we'll just do one more. We'll talk about, let's see, can we use our Leica RTK network with Skycatch or DJI RTK drones? Yeah, so this is interesting. This is a question about our network RTK, and the short answer is yes. So if you have a network RTK license, I believe both the Phantom 4 and definitely the Skycatch system support, recording observations virtually. That's something that, if you want to have more information on that, feel free to reach out to us about using RTK networks, because having this no infrastructure in the field type of setup is quite an interesting one. So many different sources for base data, and a few options for processing. You know, if you're really eager to get that fast turnaround time, I think the Skycatch Edge1 is something that's quite unique in the market right now for delivering that data. So I think we're just about up on our time, and I'll hand it back off to Jackie to sign off.
So thank you everybody for joining. For more information, we can be found at skycatch.com. We have another webinar coming up on January 22nd, Robots, Rework, ROI, Optimizing Construction Operations with Drones. And that link can be found on our Skycatch Twitter, our Facebook, and our LinkedIn. And Will Pryor will be hosting that one as well. For more information on DJI, you can see the links there. We thank you very much for attending Precision Data 101, RTK, PPK, GCPs, and what they mean for you. Thank you.